All right, everybody, welcome back to organic chemistry, continuing our exploration of nomenclature. Here's a molecule that's got multiple rings. When you see a molecule like that and you have to name it, it's a bicyclomolecule. The most important two carbons in a bicyclomolecule are what's called the bridge heads. And they're easy to spot in a drawing. I'll put them in blue. That carbon and that carbon are bridge heads. One of them must be number one. That's a new rule. And what I'm going to do here, it's going to be a little weird, but I'm going to do the naming of this at the same time I'm drawing this clearly a bicyclomolecule here as well. In fact, when you see bicyclo in the name, first thing you do, draw the two dots. Seriously, I'm gonna do it right now down there. They can be horizontal, vertical, doesn't matter. There's the two dots. Now the question is, what does the 5 mean? Here's what the 5 means. These are bridgeheads. There are 5 extra carbons between the bridgeheads in one of the rings. That's what the 5 means. 5 new carbons that connect this to this. So in total, there'll be 7, right? The 2 dots and then the 5 new ones. You ready? Here they come. And it doesn't have to be pretty, everybody. 1, 2, 3, 4, 5. Well, it's starting to look like a Burger King commercial here. Okay, I got the 5. You know what the 4 means? Same thing as the 5, except there's only 4 carbons between the dots. Start over. We'll go in red this time. 4. 1, 2, 3, 4. Then goes to the dot. 4 new carbons between the dots. It's pretty easy. And then the 3, you probably know that's 3 carbons between the dots in a different ring. 1, I'm going to lower it just a little. Oh, not that much. 2, 3. There you go. Now I'm going to make my dots big. Just so we're clear, those are dots. And similarly, since we're on that rule right there, let's go back to our first molecule and do just the bicyclo square bracket, number, dot, number, square bracket. Because that's part of the bicyclo name every time. So we're going to do that part. Bicyclo. And hey, try to take a guess. What order does the numbers have to be in? Smallest last, biggest first. Yeah, that's the convention, people. You're just learning the rules. You don't have to like them, but you got to obey them. Okay. All right. So it means I'm gonna find the biggest number of carbons to get from dot to dot, and I think it's to the right, isn't it? And I think it's 6. 1. Don't forget, don't count the dots. Remember, if you did that, carbons would get counted multiple times, and that never happens in nomenclature.
Can you start over there?
You can start down here or up here. We don't know which ones yet. That will be answered shortly. But to get the numbers, it doesn't matter which way you go. 1, 2, 3, 4, 5, 6 carbons between the dots goes first. And we'll do that in green. No, we use green. 6. Next biggest bridge is to the left. And I believe it's 4 extra carbons. 1, 2, 3, 4. 4. And then in the middle, it's a 3. A 1, a 2, a 3. And did you know you have enough information to figure out how many carbons are in there? It's easy. Count the numbers, add them up. And then the 2 dots actually that are in the parentheses, those are carbons. Those are the bridgehead dots. You see them? Don't think of them as periods, they're dots. So 10 plus 3 is 13, plus the 2 dots is 15. How do you say 15 in nomenclature? Always. Pentadec. Yes, and it's an alkane, so pentadecane. You could verify by counting them all. Sorry, I kind of wandered over to the, oh. Sorry.
Professor, my question was if you could start the one all the way to the left, all the way over there at that single one.
Oh, no, it's got to be one of the dots for one.
Okay. So
That's a new rule. We got to obey it. So I think what she's getting into, how do you decide which of the dots is number one? And there's always two ways to do it. Just like when it's in a chain, you can go left to right or right to left. There's always two possible ways, and usually one's better. Same story here. We're going to go on the outside, one, and you go to the biggest ring first. That's a rule. Have to obey it. So 1, 2, 3, 4, 5, 6, 7, 8 in red, and I'll go with baby blue here. 1, 2, 3, 4, 5, 6, 7, 8. And we have not encountered a group yet, have we? So we can't make a distinction between the red and the blue yet. But the next rule is, where's number 9? It's in the next biggest ring. So don't go to the middle, it's to the left. So in the red system, the 9 would be here, and the 10 would be here, right? And you're worried where, I'm not going to finish the numbering in red, because red's dead. Because the blue's better. Why? Well, where would number 9 be in blue following the rule? You can't go to the middle because that's a smaller bridge. You got to go there. And hey, you get a group on 10. Which method's better? The one that puts a group on 11 or the one that puts a group on 10? 10 wins. So red is gone forever. Blue wins the day. And if you want me to finish the numbering, because it's our first example, you will get to 15. Where's 13 going to be? You got to number everything in the ring. You can't use number 1 again, blue 1. So as close as you can to 12 is where you put 13 without counting a carbon for a second time. Hey, and as promised, you got to 15. We knew that. Pentadecane, right? And there are 2 groups on 10. What are the names of these 2 groups on 10? There's a single carbon group here, a methyl that goes by M, as in Mary, and then a 1, 2, 3, 4 carbon group. That's a butyl. That's first, right? B before M. So 10 butyl and 10 methyl, both in the name. 10 butyl. 10 methyl. And that's all I really need. That didn't come out very nice. 10. I just want it to look nice. There.
Can you tell me where you got penta from? Because penta's 5.
15. Penta followed by dec.
Oh, okay.
5 plus 10. Yeah. Yeah. A little like the French.
Yeah.
Like they say 16 in French by saying 16. It's backwards, but same idea.
And then can you let us know again how you got 6, 4, 3?
That's carbons between the dots. The 6 dot 4 dot 3. 6 carbons between the dots going from 1 to 8. There's 6 new carbons there. 1, 2, 3, 4, 5, 6. 4 carbons between the dots going here. 1, 2, 3, 4. And 3 in the middle. 1, 2, 3. Never count the dots again.
Oh, okay.
The dots get counted once, and they're counted here and here.
Do you do it from biggest?
Biggest rings first, yes.
Okay.
That's the rule. And since we know the rules, I'm going to go back to that last example. And hey, there's no right or wrong way to start the numbering, as long as you know the rule. If I put the 1 here down on this one, where must the 2 be? Give me a direction. Up, yes, I like your up, because that's the biggest ring. 2. And I'm not gonna show all the numbers this time. 1, 2, 3, 4, 5, 6, 7, 8 has to be with the biggest bridge. That's the red. We've already done the green. And that's 8. And we had a group on 12. 9, 10, 11. 12. It's way over there. And how do I draw that group on 12? How do you draw that 12-hexyl? 1, draw a bond to the group and draw a hexyl at the end of the bond. That's 1 carbon already you drew there. 1, 2, 3, 4, 5, 6, 10. A little carried away at the end there. That's nice. And I don't think there's anything else to that molecule. So bicycle is not too bad. It's got a couple new little rules. And we're gonna tinker with groups now. We saw that we haven't seen any new groups here. There's a cyclobutyl group though. Oh, what do you think that is? We haven't seen that before. How do you know it's a group first? Cyclobutyl is a group. How do I know that? It's not at the end, and it ends with YL, right? Okay, good. And it's a square, that's cyclobutane, but it's a group, so it's attached to our bicyclo ring system on carbon number, well, it's not a bicyclo ring system. Sorry, it's on carbon number 4 of a chain called nonane, isn't it? That's what that says. Cyclobutyl is on carbon 4 of this chain called nonane. That's what that name says. And also on 4, there's a methyl. And I just noticed my name has a mistake in it. Oh, I like that. That's a learning experience. If I was to redraw the name properly, alphabetically, this group goes by C, which is before the letter E. I'm underlining the things that need to be alphabetized. You don't alphabetize triethyl by T, right? That'd be like, you got 3 twins living at home, that's T. You have 3 of them. You chose to call them T instead of their names. I don't know. Their names are ethyl, right? That example. And that just means you move this whole chunk. If you had to name this molecule properly, that part should be ahead alphabetically of everything. There you go. That does not prevent you from drawing this molecule, even though there's an error in the name. Okay? And let's draw a nonane. That's how I start. I got the name of a chain at the end. Always start there. Nonane. How many carbons in nonane? 9. Nice. That's good. Good melody. Good harmony. That's sorry there. 2, 4, 6, 8, 9. There you go. And on 4, I can go from left to right or right to left. I'll go right to left. 1, 2, 3, 4. There's a methyl. Let's do it in a different color. A methyl and a cyclobutyl. How do you draw a cyclobutyl? Well, there's the bond to the cyclobutyl. Please make sure one of the corners of cyclobutane attaches to that. I'll show you how it should look. I'll show you the mistake I see almost every semester until I started saying I see this almost every semester. And then occasionally it doesn't happen. But there's going to be a student who tries to draw cyclobutane like that. I hope not. And they did not draw cyclobutane. What did they draw? A cyclopentane, cyclopentyl, right? I'm going to count the carbons in there. That has to be a carbon. It's the intersection of sticks. 1, 2, 3, 4, 5. Cyclopentyl, sad face, because it's not the one we wanted. That's just an aside over there, okay? All right, so we got our 4-methyl, we got our cyclobutyl also on 4. This is carbon 4 right here, carbon 4. On carbon 3, there's an ethyl. How many carbons in an ethyl? 2. So there's 1, there's 2. On carbon 7, that's 3, 4, 5, 6, 7. There's another ethyl. That's 2 of our 3 ethyls. And the third ethyl also on 7. Yes, carbon 7 has 2 groups on it.
Can we put it on the opposite side?
Yeah, you can put one up, one down, one left, one right. If you want to get real picky, on carbon 7, there's like 3 ethyls right there. So really, one of them was part of the chain, so you can't really say that. And I think we got it. Carbon 3, carbon 4. Put some numbers on just for when you're studying. You don't have to put the numbers on the test. I'm just going to grade the picture. And then the next one. Next one has cis in the name. What does that mean? On the same side. And from what we know so far, we're only talking about rings for cis and trans on this next test, the first test. Later on, you'll learn it's a little more general than that, but we're not ready for more. This is enough. So if you're on a ring and you're cis, 2 groups are cis on a ring, that means they're both either up above the ring, or they're both below the ring, or if the ring is in the plane of the page, they're both sticking at you. Those would be wedge, right? And since we're doing our answers on a page, I think that's a good way to go. Or they could be dash, both sticking away from you, right? As long as they're both the same type of bond. That's what cis means. They're on the same side of the ring. So I'll draw a couple examples. They're both going to get full credit. Please, you just give me one. You're going to start by drawing cyclohexane. That's just the old hexagon. Need a couple because I'm going to just show you 2 ways to do cis. On carbon 1, there's an iodo. What does that mean? That's a new group. It's just the element iodine as a group on the periodic table. It's I. And here we go. And don't worry about wedges and dashes till later. So on both my examples, I'm starting the same. And then on carbon 4, 1, 2, 3, 4. What do you draw on carbon 4? Pentyl. How many carbons in a pentyl? 5. The first one's the one off the ring. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And how do we make it cis? What are the 2 ways? Because I'm going to do one the first way you say. Wedges, both, yeah. And I'll do those in green. This is above the ring. And so is this. Make sure your wedge goes all the way. Do not stop wedges halfway. I'll put it aside for that in a second and tell you why it's wrong.
Does it have to be on the eye?
It has to be the 2 groups on the ring.
Oh, okay.
In this case, iodine and pentyl. And the next one, what's the other way to do cis? Dash. And the easy way to do dash is just like pretend you're making it into a zipper. Looks like a zipper, doesn't it? Yeah. So either way is good. Okay, and here's an aside. These asides are things to avoid. And I'll just show you something I've just seen many times over the years. They'll do the approach that I just did, but then they'll do the dash and stop at halfway. Uh-oh. What you've just done is introduced a carbon at the end of the dash right there. This group's not an iodo anymore. It's an iodo attached to a methyl. So a little comment. This is now a C. The end of the dash is a carbon. Now up here it wasn't because the dash went all the way to the iodine. See that? So it's clearly not a C. All right, so the group is now down here, it's wrong. You're gonna lose a half point. Iodo is attached to methyl. Yes, this is a system of nomenclature that helps us if used properly, which we didn't do. Stretching out my little aside there. Okay, another sad face. Oops. Okay, keep those sad faces off your test. And that's it for our first activity of the day. We'll continue with nomenclature. Our next activity, we're going to talk about a systematic way of naming groups and isos and sex and terts as prefixes in groups. So let's get into that.